Okay, so coupon bond scraping. First, go to Google Colab, colab.researchgoogle.com/shop create new, and then you create this one. Okay, then copy this part, copy, and paste over here, and then run. Control Enter, then it runs. Run. Then you will have something like this. Let me magnify it. Oh, let me magnify it. Okay. Okay, magnified. So first, I'll import the pandas as PD and sklearn, okay, sklearn to run regression, and stat model.api is another package to do statistical analysis, and then purely for aesthetic purpose, I imported this one, tabulate. So suppose I have bond data. So we have 1, 2, 3, 4, 5. Okay, we have a 5 bond. Okay, we have 5 bond, and then their bond prices are. This is unrealistic, but anyway, their bond prices. Okay, and it is coupon rate, coupon per 100. So per dollar, it is like. So it is 2.25%, for example, right? So it is coupon rate per year. So maturity is 1, 2, 3, 4, 5. Okay. And then now let's assume face value are all same. All same. And then to see this bond data better, I print out. Actually, you can simply, instead of this one, you can simply type bond data 0. You'll have this one. That is maybe fine, or you can print. Then it is ugly. So right, right. So this is too ugly. So to make it prettier, I print out tabulated one. Tabulate. So bond data header key. So this is the key. Name of the information, name of the column, header key, and table format pretty. Okay, and then we have a pretty table. Looks like this. And then now we have interesting one. So we have 5 bonds. So bond price looks like this, coupon looks like this, and their maturity and their face value. So we have this 5 bond, and from this 5 bond, we want to recover. We want to strip 0 coupon bond prices. How to do that? Then one easy way is we can simply create another table that clearly shows the future cash flow. So let me do this. So writing code, then how to do that? Actually, we can use exactly the same one. So let's create data called bond data. Bond data. Another data called bond data. And then enter. Okay, bond data. And then let's copy and paste the bond prices, this one. Okay, copy bond prices. First one is bond prices. Oops, second time. I do second time. So bond prices. And then we can create cash flow for the next 5 years. And then Y1, something like this. And Y2, Y3, for the next 5 years, Y4, Y5. Okay. Now we wanna fill the cash flow for each 5원. Okay.
저 교수님 마지막에 Y3로 입력하셨습니다.
That's a good point. It should be Y5. Okay. So, of course, we can print, tabulate, what? We can do exactly the same thing as before. Print, tabulate what? Bond data, bond data, right? And then header is same to before. Headers keys, and then what? We want table format, table format again pretty. Then we have something like this. So we have a bond price. For each bond, they create cash flow for the next 5 years. So we can do one by one. So, well, let me, yeah, okay, slightly. So I can see everything together. The first one is pretty straightforward. First cash flow, right? First cash flow is just maturity 1 year. So after 1 year, it gives cash flow of what? 102.25, right? Right? Because for the first bond, the coupon rate is 2.25%. Face value is 100%. So it gives you coupon of $2.25 for the next 1 year. When actually at the end of next 1 year, but then maturity is 1 year. So by the end of 1 year, you also receive face value. So at the end of 1 year, you receive both face value and coupon. So it is $100 plus 2.25, right? And then for the next 5 years, it gives you nothing, right? Zero, 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 right? So its cash flow looks like this. And the second cash flow is what? For the second cash flow, it gives you $3, right? $3. Actually, let's put point over here to make it real. $3. And then at the end of second year, I don't need a comma over here. At the end of second year, now it gives you $1.3, right? And then next gives you 0, 0, 0, right? So cash flow, second cash flow $3 and looks like this. Okay, isn't it okay? Any question? It is much better than Excel, right? Oh, let me put point over here. Point. Okay. Now third bond is what? Third bond is now coupon is $2, right? Coupon is $2. So $2 and $2, and then here another $2, $2, and then at the end of third year, now maturity is 3 years, so we receive 102. And then here 0, here what? Here 0, and then point us. Let me pick point, right? So 2 to 102, 0, 0. We can do same thing for the fourth bond. Fourth bond is coupon rate is 2.5. So let's point 2.5. 2.5 and then 2.5, and then here we receive 102.5. Oops. And then no cash flow, fifth year. Let me check. So 2.5, 2.5, something like this, right? And the final bond, longest one, is 1.75. So first year pays coupon 1.75. Second year, another coupon 1.75. Third year, another coupon 1.75. Fourth year, 1.75. Fifth year, now 101.75. Right? So we have this future cash flow, right? Good. Any question?
Sir, I have a question.
Yes.
Isn't the first element of Y1 it's 102.25, not 102.5?
That's a good point. Thank you very much. Right? It's 2.25. So now, is it okay?
Yes.
Okay. Okay. Good. Thank you for the, what is your name? I have to
전모건입니다.
remember you for class participation. What?
전모건입니다.
Okay. So you just contributed to our class. So I will remember you. Okay. Good class participation. So any other question? Actually, instead of pretty format, okay, instead of pretty, let me write PSQL. They are similar, but now I have, right? So for decimal point, I have now ordered. So they are aligned in the decimal point. Actually, pretty is better. And then next one is, okay, so we know what we wanna do is we want to calculate the price of a zero coupon bond, right? So if we multiply first zero coupon bond, Y1 to this one and to this one, then the price should be that one, right? So in the next week, 가다영 asked the question of bootstrapping. So bootstrapping is, this one is ideal settle for bootstrapping. So bootstrapping, ideal bootstrapping like this. First zero coupon bond price is very easy because if you multiply zero coupon bond price with this one, then price is this one. So the first zero coupon bond price is basically this one divided by this one, right? So you can get the first zero coupon bond price. Then you multiply here, then you will get the cash flow, this one. Then you subtract this one from here, right? And then the ratio between this one and this one is the price of second period zero coupon bond. Okay. But then for third one, since you know zero coupon bond price for Y1 and Y2, you multiply Y1 zero coupon bond price, Y2 zero coupon over here, add it and subtract from this one. Then you know present value of only this one. Then again, you can get the ratio between the two and then third zero coupon bond price. Similarly, you have now zero coupon bond price for Y1, Y2, Y3. So you multiply that one, calculate the cash flow current value of 3, 1, and subtract that value from this one, and get the ratio between these two, then you will get the fourth one. Finally, now you have a zero coupon bond price for everyone. Now, simply sum product or multiply that zero coupon price to these cash flows individually and sum them all and subtract from this one, then you will get current value of this future cash flow, and then ratio between that future cash flow will give you the fifth one. That works for this one. But what if there is some mixture, right? If this is also third year, sometimes there are like empty one, then we cannot generally use bootstrapping method. So we can use bootstrapping method only for this specific situation. For more general situation, we have to write down equations for the price of this one, and then find the price of zero coupon bond. That makes the difference between the estimated price and observed price, and minimize the sum of the squares of that pricing error. Since bond price are linear combination of future cash flow, linear combination in which the weight. So basically, bond prices are weighted average of future cash flow, and that weight is all zero coupon bond price, and that is weighting is basically linear. So solving the minimization problem is equivalent to the linear regression. And I will show you the method of the linear regression to do this one, okay? To run linear regression, okay, what we have to do is we have to use pandas data frame. Pandas data frame. So let's write down pandas data frame over here. So let's call df. And the pandas we implemented already. Pandas over here. So pd from pandas library, we call data frame. And then after that, we change our bond data. Name of the data, bond data. Bond data. Actually, it works, but then we have column names. Columns. It is very convenient. It shows you what I have to do, right? The columns, and then this is basically the name of our columns. So the name is what? We have bond price is Y1, Y2, Y3, Y4, Y5, right? So we have column name is bond underbar prices, right? Bond prices. And then Y1 to Y5. So this is a bit long, but Y1, Y2, Y3, Y4, Y5. Okay, good. And then we do this one. And then actually, let me move this one. Instead of tabulate this one, I will tabulate df. Okay, they are same. And then let me print bond prices and then their associated cash flows over time. Okay, so I have a title, looks like this one, the name of the table. And then, okay, first, okay, and then we can jump. And then we to another coding here. Okay, so why I want to do regression? Okay, so first let's define y. Y is dependent variable. So this is the target we want to fit. And then this is bond prices. and X is our independent variables. We have two, one, so y4, and then y5. So we want to regression such that we want to explain bond price with each cash flow, and their coefficient is our zero coupon bond price we are interested in. So first, this one, we want to do the regression. So regression. So we want to do regression such that we want to do the, we imported the linear model over here. Linear model. In the linear model, we want to do linear regression. Linear regression, this one, okay. Linear regression. And then in the linear regression, usually in the regression, we have constant term, but because we want to explain the prices only with cash flow, so we don't need constant sum. So insert step, so hit intercept equal false. And then we do the regression, regress. We run regression such that fit X and Y. Fit Y with X, right? That's what we want to do. And then let's try run. Okay, so regression run successfully. And then we want to see the result. So first, print. Intercept is 0, but just in case, let's check. Intercept. And then we want to see regression dot intercept. Okay, so let's see. So intercept is 0 because we hide basically intercept, so it is 0. And then print. Now important coefficients. Coefficient 0 coupon. 0 coupon bond prices. They are basically coefficient. 0 coupon bond prices are this regression coefficient. Here, our model REGR. So regression, and then regression what? Regression coefficient. Where is the coefficient? Here. Okay. So they are zero coupon bond prices basically. These one are zero coupon bond prices. Okay, basically they are zero coupon bond prices. Okay, so we got zero coupon bond prices. Okay, so that's very easy, right? By regression, we can get zero coupon bond price very easily. And then from zero coupon bond prices, we want to compute yield to maturity, right? And then we want to calculate yield to maturity. So print yield to maturity. And then for yield to maturity, it is we want to use the formula, so such that the formula is the relationship between yield to maturity and then zero coupon bond price is, as you know, the relationship between maturity and zero coupon bond prices, as you know. So prices, price equal face value multiplied by discount rate, which is minus RT, right? So we use this formula. Style is not pretty. This is fine, but not so pretty. So, okay. And then we know price, and we are interested in calculate R, this one. So we have to take log. And this one. In case of zero coupon bond, the face value is simply $1, right? It is 1. So what we have to do is we divide each side P and we move E minus RT over to the left-hand side and take log each side and divide by T, then we will get the answer, right? So here, yield to maturity should be first regress coefficient, okay? They are same, and then we wanna take log. Right, log is not defined, so I have to call log, right? I have to call log from numpy. So here, okay, from numpy import exp and log, okay, and then we take log. Actually, it should be minus, right? So this is basically gross return. Then I have to divide each one. This one is okay. I have to divide this one with 2, divide this one with 3, with this one with 4, this one is 5, right? And then what we can do is we have to import numpy and then np divide this one with series of, okay, maturities 1, 2, 3, 4, 5. No, okay. This should be comma 1, comma 2, comma 3, comma 4, comma 5. Now we have yield to maturity, right? This is yield to maturity, right? So again, what we did is through the regression method, we compute the zero coupon bond prices, and then we also compute the yield to maturity. Okay. Let me change the name. Coupon bond stripping class exercise. And then for you, I can share this one. Anyone copy, and then yeah, over here. Yes, this is much better. All right. Now you can check it. I'll come back here again. Is everything okay until now? Do you have any question? Please stop me if I'm too fast. There are another method. There is another method. So actually, I'm logged in with another device, but I cannot see it. Is it going well? Okay, it seems. Okay. Uh, okay, it works fine. Sorry, I was checking the screen. Okay, it works well. And then this is easiest way to do the regression, but actually there are another way to run the regression. And then let's use another code. And then here, let's use the test model. Print with test model. And then here, we import this test model.api as SM. So we do basically linear regression model, OLS, and then we regress y on x dot fit. Okay, so let me try with this test model. Good, it works. And then we save our model as model. Okay, with this test model, we saved it. And then we want to see the result. So print model dot summary. Model dot summary. And then we have this one. Oh. And then runtime warning divided by 0. Why divided by 0? Okay, anyway, let me try. It's strange. Print the result. Parameter, model parameter, we estimated it. Then, okay, we have exactly same value. So this one should be same to this one with stat model, 0 coupon mode prices. And then print, let's also print. I can understand why we have errors. Print model. Okay, and it shows regression result. So this is regression report. So we run linear regression, bond prices, and then one interesting part is that R square is 1 because we have 5 bonds. Basically, we have 5 equations and 5 unknowns. 5 unknown, 0 coupon bond price. So it has basically perfect fit. Okay, perfect fit because number of equations, number of data are same. So everything is standard at infinity, t0. So we have this one. But anyway, we have exactly right coefficient. Okay. Now I want to give you some quiz. Okay. So at the quiz, okay, to the homework, quiz for not homework. I think we can do it right now. So what I want to do is, okay, now text. Suppose we have additional 5-year bond, whose price is, let's see, whose price is 99.1234, okay? And coupon rate is it should be slightly higher than this one, so like a 2.13. Okay, of course the face value is 100, same. Face value is 100 and the coupon rate is that one. Then how do the zero coupon bond prices change? Okay, how do the zero coupon change? As we include the bond into the data. Okay, so it is quick. So I will give you about 5 minutes. All you have to do is change code slightly and get the answer for 5 zero coupon bond prices. Okay, and so I'll copy this one, and then again I'll open Google Form, close this one, and then create new one. Okay. Okay, quiz. So I want to make it quiz. Make this a quiz. No, not quiz, not necessary. So quiz on today is quiz, and the question is, I think it is a paragraph data. Okay, and then send. This is pretty interesting. Google is such a wonderful one, right? And then I can give you quiz. I'll shoot you quiz. Okay, I will give you, this is 2:10, so I'll give you approximately 10 minutes. So why don't you solve this problem? So the answer should be 5 bond prices that reflect this new information. So start. I'll give you 5 minutes.